S1, find the vertex and zeros of a given quadratic function. The quadratic function could be given in any of a number of ways, but it can be reduced to f of x equals ax squared plus bx plus c. Zeros by the quadratic formula. And the quadratic formula says f x equals 0 if and only if x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. This thing under the square root is called the discriminant. When it's positive, you have two solutions. When it's 0, you have one repeated solution. When it's negative, you have two complex conjugate solutions. Okay, so as far as the graph is concerned, you're only interested in real valued solutions. If you have complex solutions, you don't have a 0 on the graph. Okay, so anyhow, that's what it says. From the quadratic formula, you can pick the value halfway between the plus and the minus, halfway between the two zeros, and that's the axis of symmetry. To get the coordinates, the vertex lies on this axis. To get the y-coordinate, plug the x value for this axis, this x value, into f of x. So we can kind of summarize this. It's not something we memorize, but the vertex follows, it follows that the vertex is at negative b over 2a, the x-coordinate, f of negative b over 2a, the corresponding y-coordinate for this function. And your graph, and this is something that you should be pretty familiar with, might well look something like this. You have an axis of symmetry. You have your vertex. The axis of symmetry is that x equals negative b over 2a. I'm not going to bother to label it. We've seen it many times. And the x and y coordinates that you get by plugging the y-coordinate that you get by plugging this x value into the function is the y-coordinate of this vertex, and the x-coordinate is obviously the x-coordinate of your axis of symmetry. So, that's the bottom line. Now, there's more that we could say. If this is the case, then you have a vertical stretch by factor a. You have a horizontal shift of negative b over 2a, and a vertical shift of whatever you get when you plug that in to the function. So the other form of the function it follows is a times x minus h squared plus k, where h is this coordinate, because that corresponds to a shift to the right, and k is the vertical shift, and the vertical stretch remains, because if you expand this, you're going to get an a in front of the x squared, and clearly that a, if we understand transformations, is your vertical stretch factor.